So we got here a stack of plates. Pretty exciting, isn't it? All right. So it's not just a stack of plates. I'm going to use this to teach you an important computer science data structure. So you want to take a plate out of here. Maybe you want to take the middle plate out. Oh, but it's getting caught. Oh no. Well, we just learned what not to do. With a stack, this data structure is a stack, you can only take it from the top. And you can only put it back on the top and push down the stack one at a time. And if you try to push one back into the middle, the structure won't allow that. Oh no! So we got to put them on the top. Now, as far as pulling them off, it's kind of the same thing, right? But you can also peek. So we can look at the top of the stack and you can see the plate without taking it off. And those are the three operations: push, pull off the stack, and peek. All right, I'll show you it now with some code. Thank you. So if you couldn't tell by my video, all we're really trying to do is to show you that when you build a stack, you can only add to the top and you can only remove from the top. So we're saying this is the last one that was added is the first one that's removed. They call that LIFO. So the last one that's added is the first one that's removed. So we are always adding new items in this direction, and we're always taking items off in this direction. When you get down to the last item, there's nothing that can be taken off, and the first one that's added is always the top of the stack. All right, guys, let's build that stack. All right, so I put together two classes here, a node and a stack. The node is going to be the plates in the stack, and the stack is going to be what creates and controls those plates, right? It'll have three methods: push, pull, and peek, just like we talked about earlier. Now, there are a couple ways to implement this. The most common ways that I've heard of is with a linked list and with an array. You got to store that data somewhere, but they're both very easy. In our case, we'll do a linked list. It's just a little easier to look at. So let's start with the node class. So each plate should have the concept of what plate is under it, what's touching it. And we also should put the data that we want to show. What is the plate? We could have several properties in here or just one. In our case, to make it simple, we'll just have one, and we'll have it be a string, and we'll call it my node data. Okay. And then over here in the it should also know the concept of what's next. So let's also have another property of node, the next node. Okay. Over here in the stack, we're going to go ahead and build that push one as well first. So, but before we do the push method, the stack should know how big is the stack, because if it's a linked list, you have to traverse node to node to node to node and count at each traversal, and then return when you get to the end the size. Or if we just keep that as a separate property, it'll be much quicker to return it as needed. And so that's how we're going to handle that. So let's have a property. It's going to be an integer. It's going to be the size. We also want to keep track of the top of the stack, so it could be accessed at any time. So that's going to be property node top. Okay. All right, so let's go ahead and do push first, because we got to construct the data so we have something to work with, something to show, right? So let's do public push, public void, because we're not returning anything, push. And we have a string for our node, so we'll take in a string. String to push. And let's construct a new node. So node, new node, equal to new node. And it'll take in the string to push as we could create a constructor in node, or we could just skip that and just say new node. Since it's a public property, we don't need to do it that way. We can go this way. My node data, we called it, is equal to string to push. And now the new node dot next node. We'll go ahead and assign that next link in the linked list, and it's a singly linked list. I don't know if you noticed there wasn't a back over here in node. I'll show you. There's a next node, but there's not a previous node. It's a singly linked list because we're keeping track of the top. That's how we can get away with that. All right. So next node is equal to whoever's on the top currently. And we're going to have to increment that size. All right. I guess that's about it for that one. Let's go ahead and do the pull now. And the pull has to return a node because we're taking a plate off of the stack, right? So public node pull. And it doesn't need to take anything in. All right. So let's go ahead and identify first, is it empty? So if the size is 0, then we'll just return null because there's no plates to return. That's the best we could do, right? Otherwise, we keep going. And when we're finished with it, we need to remember to decrement. And I always put this at the bottom of the method because if it throws an error for some reason in your code, you don't change the size of the stack if you really haven't done anything to it. So, all right, so let's go ahead and take care of that pull. And I called it pull. I meant to say pop, but I think you guys understood right away what I was talking about because I'm pulling the plate off the stack. So I am popping the stack, right? So let's go ahead and take care of that. All right, so let's create a temporary node to figure out what we're sending back because it's the top, right? You can only return the top. So node top node to return. How about that? Is equal to top. And then let's figure out what the new top should be. So top can be top.next. All right. There's one thing we haven't done yet, and that is we have not returned. So let's return the node to return. So we did have a bit of a swap there, right? So pretty simple. All right, so we've done push pop. Let's do peek. And that's going to return a node as well. And once again, if it's empty, there's nothing to send. The only difference is we're not going to be decrementing. So we could just return the top at this point. All right, let's give it a try, shall we? So let's create a stack. My stack equal to new stack. My stack dot push. And we're going to push hello 1. And then let's push a few more like that. Hello 2, hello 3, and hello ABC. All right, now let's do a for loop just to get all these items off here. So for int I equals 0 equals 0. I is less than 0, 1, 2, 3. Less than equal 3. I plus plus. And let's do my stack dot pop node, temporary node for displaying. How about display node? Display node equal to my stack dot pop, and display node. The node we want to get out of the data we want to get out is the my node data. So let's just console write line that stuff. And then we'll put our reader at the bottom like usual. Console.readline. To stop for input, I'm hitting F5. Uh-oh. Object not set to an instance of an object. Let's see what's going on. So when we got into our pop, which is called from this for loop here, and we're looking at the iterator And we can look at our call stack. The I is 0. So this is the first time through. It's trying to pop it, and it's saying that the top is null. Well, that was assigned in push. So let's take a look at push. When we push the items onto the stack, we never assign the top. So this is a great troubleshooting lesson. Right here, we'll just assign that top. All right, so if we push the first time, if it was the first node being pushed, then I think it just equals this. Either way, it equals this, because we said that we only push onto the top of the stack. So the top of the stack is always the one that we just pushed. That's why they call it last in, first out, right? So the one that you pushed is the one that's going to be pulled out. So the top is the one that was just pushed. So let's say top is equal to new node. And that should solve it. I'm gonna go back and hit play. There you go. Hello ABC 321. Now you'll notice this is in reverse order of how we entered them, because imagine your plate's coming down, and the last one that you entered is ABC, then 3, then 2, then 1, right? Now let's do peak, just to show you if I did peak, or actually not here, let's do peak right here. Let's say node to display node and node 2, and we'll do peak then pop, and we'll console right line them both, and it's underlined in green because it's still running. And node does not contain a definition for display node 2. Oh, oops, that actually I meant to put that here. Okay, so now we're displaying the first one and then the second one, and what we should see is we should see everything displayed twice. This twice, then this twice, then this twice, because peak doesn't remove items from the stack. This is all really simple stuff, I know, but it's fun, right? There you go. 2 ABCs, 2 3s, 2 2s, and 2 1s. Well, now you've seen the stack, and hopefully you'll remember that it's incredibly easy after watching me do it. And that's all there is to it. I hope you guys have a great day.